Hi everyone, I am Vanita. I am doing BE in Electronics and Communication Engineering in SVCE Bangalore. I am from Honda section. Today my subject is Introduction to Civil Engineering and the topic is numerical based on centroid. Definition of centroid. Centroid of a body is a point at which the area of the plane figure is assumed to be concentrated. It is represented by CG or G. The centroid of the gravity are at the same point. Centroid is also known as moment of inertia. Applications of centroid, which is important for stability and balance for structures such as bridges, buildings and ships. The knowledge of the location of the centroid of a body helps to calculate moment of inertia and other important properties in physics and mechanics. Centroids are useful for many situations in statics and subsequent courses, including the analysis of distributed forces, beam bendings and shaft torsion. In the field of engineering, the centroid is used to determine the location of the center of the gravity. Now let us see about the steps for solving a problem. Step 1. Assume the reference x and y axis if not given in the question. Step 2. Check for the symmetry of the figure. Step 3. If the figure is asymmetric, then divide the whole figure into known geometrical sections like rectangle, triangle, semicircle and quadrant of a circle. Step 4. Then determine the centroid of individual geometric figure from the reference x and y axis using the table. Problem on centroid. Locate the centroid of the given composite section. Here in the given figure, the figure is symmetric. Therefore, we need to divide the figure as a geometrical sections like triangle, rectangle and the semicircle. Here x and y are the reference axis. Now let us see about the table. Serial number, component, area in meter square, centroidal distance from x-axis, moment of area about x-axis, A into y, centroidal distance from y-axis, moment of area about y-axis, A into x. Let us consider the first component as rectangle. Then the area of rectangle is B into D. Here breadth of the rectangle is 6 meter and the depth of the rectangle is 4.5 meter and the area is 27. Centroidal distance from x-axis is d by 2. Depth of the rectangle is 4.5 divided by 2, that is equals to 2.25. Now we have to multiply area and the centroidal distance from x-axis. Here we got area as 27 and the centroidal distance is 2.25. By multiplying that we get 60.75 as the moment of area about x-axis. Now centroidal distance from y-axis is b by 2. Breadth of the rectangle is 6 meter. Therefore 6 by 2 is equals to 3. Moment of area about y-axis is a into x. We have to multiply area and the centroidal distance from y-axis. Therefore the area is 27 and the the centroidal distance from y-axis is 3, that is equals to 81. Now let us move on to the second component, semicircle. The area of the semicircle is pi r square divided by 2 and the radius of the semicircle is 3 meter. Therefore pi into 3 square divided by 2, that is equals to 14.14 is the area of semicircle. Now centroidal distance from x-axis, 4.5 plus 4r divided by 3 pi. 4.5 plus 4 into radius of the circle is 3 divided by 3 pi, that is equals to 5.57. 5.77 is the centroidal distance from x-axis. Now moment of area about x-axis, A into y. We have to multiply area on the centroidal distance similarly as we done for the rectangle. 14.14 into 5.77, that is equals to 18.58 is the moment of area about x-axis, A into y. Now centroidal distance from y-axis x, r is equals to 3. Moment of area about y-axis, A into x. A into x is 14.14 into 3, that is equals to 42.42. Now the third component is triangle. The area of triangle is half into base into height. Here in the figure, the breadth is 3 meters and the height is 4.5 meters. That is equals to half into 3 into 4.5. That is equals to 6.75 is the area of triangle. Now centroidal distance from x-axis, 1 by 3 into height. 1 by 3 into height of the rectangle. Height of the triangle is 4.5. That is equals to 1.5 is the centroidal distance from x-axis. Now moment of area about x-axis, that is equals to a into y. We have to multiply both the area and the centroidal distance. 6.75 into 1.5, that is equals to 10.125 is the moment of area about x-axis. Now centroidal distance from y-axis, 6 plus 1 by 3 into b. 6 plus 1 by 3 into breadth of the triangle. Breadth is 3. That is equals to 7 is the centroidal distance from y-axis. Now we have to multiply area and the centroidal distance from y-axis. That is equals to 6.75 is the area and the 7 is the centroidal distance from y-axis. That is equals to 47.25. 47.25 is the moment of area about y-axis. Now we have to make the summation of area, summation of a into y and the summation of a into x. Here summation of a is 47.89 meter square. Summation of ay is equals to 152.45 meter square and the summation of ax is equals to 170.67 meter square. Now we have to calculate x bar and the y bar. Here the formula for x bar is summation of ax divided by summation of a. Here in the table we got summation of ax is the 170.67 and the summation of a is 47.89. By dividing that, 3.56 meter is the required solution for the x bar. Similarly for y bar is equals to summation of ay divided by summation of a. Here we got summation of ay as 152.45 and the summation of a is 47.89. By dividing that, we get 3.18 meters. This is the required solution for this figure in this question. Thank you for watching.